Hello everyone, I'm Eva Kwoll. I'm assistant professor in geography at UVic and I'm presenting on our project on the sediment and hydrodynamics of the Skeena Estuary. The Skeena Estuary is located along the northwestern BC coastline, close to the port of Prince Rupert, and it is atypical in that it is structurally controlled by a number of bedrock islands that occur in its basin. We started out by examining the seabed morphology using data from the Canadian Hydrographic Service as well as our own multi-beam data. And what is the most striking feature here is the river delta shown in these orange colors here, with variable slopes leading away and towards oceanward, as you can see here, with evidence of failure deposits as well in some of these deeper regions. While the delta extent is pretty straightforward in Marcus and Telegraph Passage, it is much less clear in the smaller northwestern passage that is Inverness. You can see the bathymetry is much more complicated, and we interpret it based on the morphology as well as acoustic backscatter and sediment samples. The southeastern portion to be still part of the delta plain, still comprising river deposits, but then the southern end of it has very irregular bedrock type geology already. In addition to the morphology, we compiled all data available on the seabed surface grain size as well as radiocarbon dated cores. We also collected a few of our own carbon cores where we thought information was missing. And then my HQP Amanda Wild went ahead and classified the seabed of the Skeena Estuary into facies, analog to what is usually done in a more sandy estuarine environment. And this paper that is forthcoming by her then compares a structurally controlled estuary to these more traditional type of estuaries. We were also struck by how little information is known about how much sediment and discharge the Skeena River actually brings into the estuary, and for that we used hydrotrend that uses basin characteristics to estimate sediment load and discharge at the river mouth. And we can see here the annual variation of discharge and both suspended and bed load transport at the mouth. This is a monthly mean over the past couple of decades, as well as seeing the clear signature of the fresh head here. And then we went ahead and estimated future changes based on different climate scenarios. The main difference I want to point out, the top figures are the moderate scenario and the bottom figures are the less optimistic scenario, is that the moderate scenario predicts an increase in discharge that levels off towards the end of the century, as well as an increase in sediment load that also levels off. This is mainly caused by an increase and then decrease in the contribution by ice melt as well as rain, and sediment load shows a decreasing trend in the contribution of suspended sediment coming from glaciers. And the difference then in the less optimistic scenario is that we don't see that leveling off trend in the discharge. Instead, we see a continued increase in the contribution coming from rain. As well, we see a more drastic decrease in the suspended sediment that is originating from the glaciers, as well as we see an overall increase, and that is this light orange color in the overall suspended sediment arriving from the hill slopes, which we attribute to this increase in rain. We're also looking at the tidal dynamics within the estuary, and for that we collected repeated ADCP cross-sections under a low river stage and under a moderate flow river stage. And example graphs are shown here from this cross-section in Telegraph. At the top, we see a moderate river flow scenario where we have evidence in the CTD casts that are overlain as well of stratification, and we see that in the velocities of the ADCP that is underneath that, we can see that the tide turns vertically with ebbing remaining at the surface while flooding initiates at the bottom, whereas under low flows, we can see that there's very little stratification and the tide turns horizontally. And we see that for each of the passages, this can be quite different and varies seasonally. So this is the end of my presentation. Thank you.